Hello students, in previous lectures we have studied about different types of methods of integration, and before that we have learned about by parts method. Now today we are going to learn about the another type of integral, that is if the integral of the type ax plus q into under root ax square plus bx plus c dx, that is, outside a square root we have a linear factor and inside a square root we have a quadratic factor. Then to evaluate such type of integral, we need to express this linear factor in terms of a into derivative of quadratic factor ax square plus bx plus c plus b, where a and b both are constants. Okay, isn't it? Now here, by finding the values of a and b by comparing the terms, the given integral gets reduced to a standard form, and then by using standard formulas we can integrate the function. So let us consider here one example, that is the help of integration of x plus 1 into root 2x square plus 3 dx. Therefore I is equal to integration of x plus 1 into under root 2x square plus 3 dx. Now this integral is of the form which is given there, that is px plus q into under root ax square plus bx plus c. You may think about where is dx. There is no term of x, but it doesn't matter if there is a polynomial of order 2, 2x square plus 3. Now let us see, that is by using the given format, consider the linear part. This can be expressed as a into derivative of quadratic term plus b, that is x plus 1 is equal to derivative of 2x square, that is 2 is constant, derivative of x square is 2x, 2 into 2 4 into 4x, and plus derivative of 3 is 0, and plus this b as it is. That is, we have x plus 1 is equal to 4ax plus b. Now comparing the coefficients of x and constant term on both the sides, we get that 4a is equal to 1. See again, coefficient of x is 1 here, and coefficient of x to the RHS is 4a, it is written here. So 4a is equal to 1, and constant terms, here it is 1 and here to the RHS it is b. So simply b is equal to 1. That is, a is equal to 1 by 4 from this equation is it, and b is equal to 1. Now using the values of a and b in this equation, here we have x plus 1 is equal to 1 by 4 into 4x plus 1. Now here 4 get cancelled. Okay, or we can write the term as it is here, I is equal to. Then replacing this term in the given integral I by this term, substitute a term here, we get I is equal to integration of, now replace this term, 1 by 4 into 4x plus 1 into root 2x square plus 3 into dx. Now here 1 by 4 taking outside the integral, inside the integral we have multiply by 4x to this root term and multiply by then 1 to this root term. So here we have 1 by 4 into integration of 4x into under root 2x square plus 3 dx plus 1 into separating the terms under root 2x square plus 3 dx. Now both these terms are in standard form. Now here we can write them as I1 and I2. So let us consider for I1 1 by 4 integration of 4x into root 2x square plus 3. Now by making substitution, put 2x square plus 3 is equal to 3. Therefore derivative of this term is 4x dx is equal to dt. Therefore I1 becomes 1 by 4 as it is, integration of here 4x dx is equal to dt here, and this is t raised to half, that is square root can be written as t raised to half. Therefore, is equal to 1 by 4. T raised to, after integration, term that is power get increased by 1. 1 by 2 plus 1 becomes 3 by 2 and upon 1 by 2 plus 1, 3 by 2. Therefore, I1 is equal to 1 by 6 2x square minus 3 raised to 3 by 2. How this is obtained? This is obtained by back substitution for t. Here we have already made a substitution, t is equal to 2x square plus 3. So here by back substitution, that is t is replaced by the original term and we will have 2x square plus 3. By mistake it is negative sign is given there, so it is plus 3 raised to 3 by 2 plus c1. Now what about I? Now I2 is equal to integration of 2x square plus 3 dx. Now this is a standard form. If we take these two outside the square root, then first we will remove from this term 2 into x square plus 3 by 2 dx. I have explained you in last lectures, that is we have to make this x square free from any coefficient or coefficient of x square should be unity. Okay, for that purpose we have to remove that coefficient, means we have to divide the terms by that coefficient. So here if we write 2 outside the bracket, then inside the bracket we have to divide it by. So here 2 by 2 get cancelled and here 3 by 2. Now taking 2 outside the square root, each root it is root 2. Since it is a constant taking outside the integral, inside the bracket we have x square and these 3 by 2 can be written as root 3 by 2 bracket square. That is this is a standard form, and which standard form? This is of the form integration under root a square plus x square dx is equal to x by 2 into under root x square plus a square plus a square by 2 into log of x plus under root x square plus a square plus c, isn't it? So here x is same but a is equal to root 3 by 2. So substituting the value, root 2 is already there. It is not in formula, it is already there. In bracket x by 2 under root a square plus x square that is root get removed plus a square again 3 by 2 upon 2 into log of x plus under root x square plus 3 by 2 plus c2. That is equal to root 2 into x by 2, this term as it is, plus 3 by 2 and upon 2, that is 2 into 2, 4, 3 by 4, log of x plus x square plus 3 by 2 plus c2. Now this is I2 and I1 is already there. So substituting the values of I1 and I2 in equation 1, we have I is equal to I1 plus I2. That is I1 is equal to 1 by 6 2x square plus 3 raised to 3 by 2 plus c1 plus root 2, substituting whole this term there and c2. Now we have to add only one constant, so collecting c1 and c2 together and we can write down, there is plus sign, remember that this is plus 1. So c1 plus c2 is equal to c. And our integral becomes, that is equal to c. Now let us have one more example. X into root 5 minus 4x minus x square. So I is equal to x into, let us consider that is I is equal to 5 minus 4x minus x square dx. Therefore here the linear factor is x only. Considering that linear factor is equal to a into derivative of quadratic factor plus b. Therefore, a is equal to minus 4 derivative of this one. Derivative of 5 is 0. Derivative of 4x, that is 4 only. Negative sign as it is. Minus sign again as it is, and derivative of x square is 2x plus b. Multiplying by these terms, we have minus twice a plus collecting the constant terms here, a into minus 4 a and plus b. Now these terms are separated as terms with x and terms without x. Now comparing the coefficients of x and constant terms on either side, we have here x is having coefficient 1, therefore minus twice a is equal to 1, and there is no constant to the LHS, so it is considered as 0, and to the RHS we have b minus 4a. Therefore, b minus 4a is equal to 0. Therefore, a is equal to minus 1 by 2 and b is equal to 4a. But a, this can be written as is equal to 4 into a is equal to minus half. So substituting it, and we will have minus 2. Therefore, this equation becomes x is equal to minus half into minus 4 minus 2x minus 2. Here a is equal to minus half and b is equal to minus 2. Remember that. Now, replacing the value of x in integral r by this new value, integral becomes I is equal to integration of, in bracket, minus half minus 4 minus 2x minus 2 into root 5 minus 4x minus x square dx. Isn't it? Now, again separating the terms, taking minus half here, minus 4 minus 2x, these terms separate term and this is the separate term, into root 5 minus 4x minus x square dx, and this minus 2 into integration of root 5 minus 4x minus x square dx. Okay. Now see how we do this separation. Now see carefully. Minus 4 minus 2x is derivative of this root term. So we want one term as derivative into that function and minus or plus the remaining function. Isn't it? Try to understand this one. So again do separation. If we separate the terms as integrals I1 and I2, then it will become easy to solve it. So for that purpose, the first integral is considered as I1 and second integral is considered as I2. Therefore, I1 is equal to, here in I1, since this term is derivative of this term, observe carefully, therefore make a substitution, put 5 minus 4x minus x square is equal to t. Therefore, differentiating with respect to x, derivative of 5 is 0, derivative of minus 4x minus 4, derivative of minus x square is minus 2x into dx is equal to dt. Therefore, I1 is equal to, after substitution, minus half is already there, you can see it, into integration of this whole term is equal to dt, c. And for this square root, this term is equal to t. So in root t means t raised to half into dt. This can be written as minus half, and after integration, its power gets increased by 1. So half plus 1, 3 by 2 upon half plus 1, 3 by 2 plus c1. That is minus 1 by 3. Here, these 2 get cancelled and 3 remains. That's why minus 1 by 3. And that substitution for this t. What is its value? 5 minus 4x minus x square raised to 3 by 2 plus c1. Now let us see I2 is equal to twice integration of 5 minus 4x minus x square dx. Now we have to reduce it to a standard form, but for that purpose we have to make for this term as a perfect square, and for that purpose we have to add a third term. Now we have learned about addition of third term, how to add it. We have to take the coefficient of this middle term into half and its square. Coefficient of middle term is 4 into half, that is 2, minus 4 into 2, sorry, minus 4 into half, that is minus 2, but bracket square is again 4. So adding and subtracting here 4, we get 5 plus 4 9, and this term becomes minus, taking minus sign common because both the terms are negative, taking negative sign common, x square plus 4x, and that added term, actually we here we take minus 4, but due to this negative sign it becomes plus 4, because plus 4 is already added with this 5 and it becomes 5 plus 4 9. This is a negative 4, but for the due to this sign it becomes positive 1. So solve it separately and try to understand it into dx. Therefore, is equal to twice integration of this term can be written as 3 square, and this is a perfect square or complete square of, taking square root of x square is x, sine of middle term and square root of last term, bracket square into dx is equal to 2, 2 is already there, and this is a standard for a square minus x square. And if you remember that I have told you, if such a form occurs, that is a square minus x square, then this is compared with the derivative of sine inverse of x, substitution. So what is its integration? Its integration is that x by 2, here your x is x plus 2, x by 2 into under root a square minus x square plus a square by 2 into sine inverse of x by a plus c. But here these are the two separated integrals. In I1 we have added c1 and here I2 we will add c2. So c again, the standard form is a square minus x square. Its integral is x by 2 into under root a square minus x square plus a square by 2 into sine inverse of x by 2, sorry, x by a. 2 is there, that's why I have repeated here. Now, x is equal to x plus 2 by 2 into under root a square minus x plus 2 bracket square as it is, plus a square, that is 3 square by 2 into sine inverse of x plus 2 by 3 plus c2. Now, the simple changes are 2 get cancelled, x plus 2 into under root. These terms solving these terms, we will have the original term, that is 5 minus 4x minus x square plus, here 3 square is what? 9. 3 square is 9 and into sine inverse of this term as it is plus c2. So 9 by 2. Now therefore, substituting the values of I1 and I2 in I, we will have I is equal to minus 1 by 3 y minus 4x minus x square raised to 3 by 2 minus this term x plus 2 into root y minus 4x minus x square minus 9 by 2 sine inverse of x plus 2 by 3. Now see students, what happened? We have separated the terms, or we remove this bracket by the multiplication of 2. Then 2 get cancelled with these 2, and for this term, these 2 again get cancelled, and that's why we have only 9 here. Remember that one. Okay. So here also 9 sine inverse of x plus 2 by 3 plus c, where c is equal to c1 plus c2. See student, this is one of the simple example, but it is lengthy. So you may think that it is critical or tedious, but it is not that type one. If you have got the formulas which I have learnt in previous lectures, then you can easily attempt these examples. So try to first understand those formulas and then try to solve these examples again for your practice. Solve these examples again by your own way. Now, let us see one more integral. This corollary is a very important corollary, and this may be asked, it is already asked in exam, board exam, and there are also chances it will be or may be asked in next exams also. So let us see what is this theorem or result or corollary. It is very easy to understand. Its proof is also easy, and it is very easy to apply to solve the examples also if you know the derivatives of the functions. Now see, integral of the type e raised to x, see exponential form in bracket e of x plus derivative of the same function f dash of x into dx. Then if we have such a form of function to integrate, then its integral is what? E raised to x, e of x plus c. See how to prove it? Let us consider e raised to x into e of x is equal to t. Okay, product of the two functions, differentiating with respect to x. So, first function into derivative of second function, that is e raised to x into f dash of x plus second function into derivative of first function. Now second function is fx as it is. Derivative of first function e raised to x have derivative e raised to x. Therefore, it does not changes. And to the RHS, derivative of t with respect to x dt by dx. Okay. Now here taking e raised to x common. In bracket we have collecting these coefficients of e raised to x, e of x plus f dash x is equal to dt by dx. Now, by definition of integration here, we want to add an integral sign. For that purpose, integrating both the sides. So here, integration of e raised to x, e of x plus f dash of x into dx, and due to integration these derivatives get cancelled and we have only t plus constant of integration c. But what is this t? Okay, we want to obtain all the terms in uniformness, that is variable should be x to both the sides. So remove this t, and what is it? E raised to x into fx. Therefore, our result gets proved, and what is it? Integration of e raised to x into fx plus derivative of the function itself is equal to e raised to x fx plus c. So see students, it is very easy to prove. If you remember it, if you do it, then you can easily obtain. If it will be asked for 3 marks, then you will obtain 3 marks. If it will be asked for 2 marks, then you will obtain 2 marks. So do it. It is too easy to do and understand and to prepare. So let us have again overlook it. E raised to x, f x is equal to t. Differentiate it. Then by definition of integration cancels derivative, therefore t by back substitution, and we get the required result. Okay. In very few steps we get proved. Now see, to understand this result, let us consider one example, which is a very easy example. Okay. It may be asked for 1 mark with this proof in exam. So e raised to x tan x plus x square x dx is equal to, by using this result directly. Here you can see e raised to x is already there, tan x. Now let us have one more example. Integration of, isn't it? Here, so e raised to x integral e to of the form 2x e raised to x 1 plus into 2x plus, now you will think that x into dx. And hence by using the above result is equal to simply e raised to x into f. So see, and what is that f? make some changes. We have to use to standard form because this is the standard C. So let's consider. So the given within a minute you can solve 2 plus sin 2x, 1 plus cos 2x. Now we know that sin 2 theta is equal to 2 sin theta into cos theta. In place of theta we have here x. And 1 plus cos 2x is equal to we have 2 cos square x. Isn't it? Now taking here 2 common and divided by these two, it gets cancelled here 2 throughout from numerator and denominator. And the remaining terms are 1 plus sin x cos x upon cos square x. Isn't it? Now there is at the denominator single term. We can separate the terms as 1 by cos square x plus sin x cos x upon cos square x dx. Therefore, E is equal to e raised to x. 1 by cos square x means what? Sec square x. And here 1 cos x get cancelled from numerator and denominator, and we have sin x by cos x. But sin x by cos x means what? Tan x dx. That is e raised to x into tan x plus sec square x. This is again of the form which we have seen in previous example, that is fx into f dash of x. So by using the result we have clearly I is equal to e raised to x tan x plus c. Therefore the given integral I is equal to simply e raised to x into tan x plus c. So let us see. First we have to reduce this function to a standard form. We have evaluate in this way, follow these steps. Okay, it is too easy to understand. And then this is a standard form, e raised to x into fx plus f dash of x. By using result we have e raised to x tan x plus c. One more example. Integration of e raised to x plus 2 by x plus 3 bracket square dx. Now this is the polynomial forms, linear functions are there. Now how to evaluate it? First again we have to reduce it to a standard form, that is integrable form. Now x plus 2, this term, adding 1 and subtracting 1. So if adding 1, then 2 plus 1 3 and this minus 1. Upon, why we do this one? At the denominator we have x plus 3 bracket square, for that purpose here x plus 3 bracket square. Now x plus 3 separating the terms, upon x plus 3 bracket square plus this minus 1 upon x plus 3 bracket square. Now 1x plus 3 get cancelled from numerator and denominator, and we have here x plus 3 at the denominator. Now plus minus 1 by x plus 3 bracket square. Now if you look at this function, this is a linear form. Okay, what is the derivative of 1 by x? Do you remember that? Derivative of 1 by x is minus 1 by x square, isn't it? So comparing this function with 1 by x, its derivative is also minus 1 by x plus 3 bracket square. Okay, if you do not get it, then see your book, reference book. In that reference book, see that chapter derivative and see what is the derivative of 1 by x. Then you will easily understand this term also. Now it is of the standard form, e raised to x into fx plus f dash of x. Now, and you here you may get one more thing, that we didn't replace this plus sign by this negative sign. Why? Because we need here to express f dash of x. That's why we didn't change it. So this is the standard form, and hence by using the corollary or this result, the integration of this function is simply e raised to x into fx, that is 1 by x plus 3 plus c, and therefore integration of e raised to x into x plus 2 by
x plus 3 bracket square dx is equal to e raised to x by x plus 3 plus c, that is constant of integration. See students, again simple conversions are there. First, the important step is that addition and subtraction of 1, okay, cancel one factor, then this term, if we differentiate it, then its derivative is this second term, okay, and now it is in a standard form, and hence by using this result we will have the required. Let's have one more example. E into sine inverse of x in bracket x plus under root 1 minus x square by 1 under root 1 minus x square. Now students, you know that derivative of sine inverse of x is what? 1 by under root 1 minus x square, isn't it? Now see how to solve it. Let us consider the given integral. Now e into sine inverse of x can be written as in bracket x plus under root 1 minus x square into 1 by under root 1 minus x square. The same function is only written in another way. See, now put sine inverse x is equal to t, therefore 1 by under root 1 minus x square dx is equal to dt, and therefore we have x is equal to sine of t. Therefore I is equal to integration of e raised to t into sine of t plus into under root 1 minus sine square t into dt. See students, here sine inverse of x is equal to t. Therefore x is equal to sine t. Pre-multiplying both the sides by sine, sine into sine inverse get cancelled, x sine of t and its derivative, this one, okay. Therefore x is replaced by sine of t. Now sine t plus 1 minus sine square t cos square t dt into e raised to t sine of t plus cos t into dt. Let f of t is equal to sine of t, therefore f dash of t is equal to cos t. Therefore I is equal to integration of e raised to t in bracket, here see, f of t plus f dash of t dt. This is a standard form again, hence by using result we have e raised to t f of t plus c. But here we have to replace this t by the value of x. But what is this t? E raised to sine inverse of x, that is t is equal to sine inverse of x into sine of t. What is this sine of t? X only, plus c, constant of integration. Therefore we have x into e raised to sine inverse of x plus c. See students, first we separate the function in this way, okay. Then we make a substitution. Here we obtain the value of x in terms of t. This term is derivative, okay. This whole term is dt only. Terms of x can be written as here in this way. Now you can simply understand sine has derivative cos. This is a standard form, therefore we get the required answer in this way by